Oh my. Relative velocity and simultaneous at the same time in this eco-friendly problem. So here we go. We have this canoe group that drops a bottle. And then they continue upstream, realize they dropped it, turn around, paddle downstream, catch up and pick up the bottle. So we have 3 bits of motion here. We have them going upstream for a time t1, which we're given, a distance x1, which we're given, and they're moving at a speed in a river that's moving the opposite direction. So their overall velocity is going to be their velocity in still water minus the velocity of the river. Then they turn around and come back down. So I have a second situation here. They go some distance x2, which I'm given. Again, they're moving with the river this time, so their velocity is going to be added to the river's velocity. And for some time t2, and this whole time this is occurring, the bottle is floating with the river. The distance of the difference between x2 and x1 here, and it flows for that whole time period that they went upstream and came back downstream. So what we have is we have 3 equations of motion we can get, which is good because we have 3 unknowns. So with 3 unknowns, we need 3 equations to solve it. So we're going to go over here to our equation number 2, and we're going to set this up. And I'm just going to do the first one for you and let you do the other 2 and then set up your system of equations. So here we go. I'm going to do the first one. So they went to distance x1. Their velocity was vc, the velocity of the canoe, minus the velocity of the river, because they were going upstream, times t1. And so now you're going to need to create a second and third equation, one for each of these other paths, and then set up your system of equations and solve.